Hey guys, happy Monday. So today we're going to start with this problem of the day, which is a review from the last section, finding the length of the arc. So remember, when we're finding the length of an arc, we're using the equation S equals R times theta, when theta is always in radians. Don't forget that, that's very important. So looking at our circle, we have a theta of 45 degrees and a radius of 12. We're not given any units here, so we'll just write in units at the end. In order to plug into our formula, we need to convert from degrees to radians. So to convert 45 degrees to radians, we multiply by pi radians over 180 degrees. When we multiply, our degrees cancel out, and we're left with pi over 4 radians for our theta. Now that we have theta in radians, we can just plug in. So S equals, R is our radius, is 12, times pi over 4 for our theta. We can simplify here. Before multiplying, 12 becomes 3, 4 becomes 1, and we're left with 3 pi units for the length of our arc. If we multiply this out, it's approximately 9.4 units for the length of this arc. And that's it for the problem of the day. Today, we're going to start section 4, which is the sine function. And the objectives for section 4 are to identify properties of the sine function and to graph sine curves. The sine function, y equals sine of theta, matches the measure of theta of an angle in standard position with the y-coordinate of a point on the unit circle. This point is where the terminal side of the angle intersects the unit circle. You can graph the sine function in radians or degrees, but unless specified, you should use radians. So when we're graphing our sine function, it's going to look something like the graph at the bottom, and these points on our sine function match up with the points on the unit circle. So for each and every point along the unit circle, the radian measure of the arc has a corresponding sine value. In the graphs below, the points for 1, 2, and 3 radians are marked on the unit circle. The black bars represent the sine value of the points on the circle translated onto the sine graph. So as we know from our unit circle, the sine value is always the y value. So looking at this unit circle, we have points 1, 2, and 3, the sine value, this black bar represents the sine value because that's our y value. It's the same if we look at our sine function here, graphed all the way out as a curve. Our 1, 2, and 3 radians, the black bars represent the sine value again, and they match up, they're the same as what it is on the unit circle. So you can see when we have our sine function graphed out on our coordinate plane, there are some key points that match up exactly as they do on the unit circle. For example, 2 pi, 0, and negative 2 pi. If we think about this on our unit circle, 0, 2 pi, and negative 2 pi are all on the positive x-axis, where our y value equals 0. Remember, sine matches up with our y value. So at 2 pi, 0, and at negative 2 pi, our y value is 0 on our unit circle, as well as on our function graphed out. Other key points, at pi over 2 and at negative 3 pi over 2, our sine value is positive 1. And at negative pi over 2 and at 3 pi over 2, our sine value is negative 1. So these points are going to match up exactly whether it's graphed out as a sine curve or if it's graphed out on the unit circle. An essential understanding for this section: as the terminal side of an angle rotates about the origin beginning at 0, its sine value on the unit circle increases from 0 to 1, decreases from 1 to negative 1, and then increases back to 0. So let's look at an example. What is the period of y equals sine theta? So this is just our sine function, and we're trying to figure out the period. So if we start, the period, remember, is 1 full cycle. If we start at the origin, and then we go up to pi over 2, and bring it down back to our positive x-axis. That's not 1 full cycle, though, because then our graph moves below the x-axis. So that's half of our cycle. And then we go below the x-axis to 3 pi over 2 and back up at pi over 2 to the positive x-axis. So one full cycle in our sine function looks like this. And the period of that function, if we're talking about radians, from 0 to pi over 2, the period is, or 2 pi, sorry, not pi over 2. The period is 2 pi because that's the length or how long it takes to get through one full cycle on this graph. The graph of a sine function is called a sine curve, so we're going to refer to it as a sine curve. By varying the period, which is the horizontal length of one cycle, you get different sine curves. So if you change the length of a cycle, that's going to change the graph and change your sine curve. So let's look at some examples for finding the period of a sine curve. First example. Use the graph of y equals sine of 4 theta. So y equals sine of 4 theta is graphed on this graph below. How many cycles occur in the graph below? And what is the period of y equals sine of 4 theta? So we're going to use this graph to figure out how many cycles occur from 0 to 2 pi. And to make it a little bit easier, we can sketch out our cycles. So from 0, one full cycle goes above the x-axis, below the x-axis, and then back to the positive x-axis. Remember, our cycles start and end in the same exact spot. So that's one cycle. Second cycle is in blue. Then our third cycle is in green. And fourth cycle brings us to 2 pi on the positive x-axis. So this graph has 4 cycles from 0 to 2 pi. And notice this 4 matches up with the 4 that's in front of theta in our original equation. So that's how many cycles occur. We have 4 cycles. To figure out the period, we know from our graph that we have 4 cycles from 0 to 2 pi. So to determine how long one cycle is, we do 2 pi divided by 4. If we have 2 pi, it takes us 2 pi to get through 4 cycles. To determine one cycle, we just divide. And when we divide 2 pi divided by 4, we get a period of pi over 2. So we have 4 cycles in this graph, and the period, the length of one cycle, is pi over 2. Looking at another example, how many cycles occur in the graph below? What is the period of the sine curve? So you'll notice in this graph, we're going to start at 0, and we can end the one cycle at pi over 4, or 4 pi. So one full cycle is 4 pi. So in this graph, only one cycle occurs, and the period is 4 pi. So depending on our function, our equation, that's going to change the period, and that's going to change how your sine function looks. You can also vary the amplitude in a sine curve. So if you change the amplitude, that's going to change your sine curve a little bit as well. So let's look at some examples for finding the amplitude of a sine curve. First example, what is the amplitude of the sine curve? Remember, to find the amplitude, we're doing our maximum value minus the minimum value divided by 2. So in this graph, we can see the maximum value is at positive 2. The minimum value is at negative 2. So to figure out our amplitude, we're going to do positive 2 minus negative 2, which becomes plus 2 over 2. 2 plus 2 is 4, divided by 2 is 2. So the amplitude of the sine curve given is positive 2. Another example, this graph is slightly different. We're finding the amplitude. We're looking at our maximum and minimum values again. So our maximum value is at positive 2. Minimum value is at negative 2. So when we plug in, 2 minus negative 2 becomes 2 plus 2 over 2. 2 plus 2 is 4, divided by 2 is 2. So the amplitude of this function is also positive 2. 2 more examples. So if you want to pause the video right now and try these, take a second. Otherwise, we'll keep moving. So for our first example, we're still finding the amplitude. Now we don't have the equation, but you have to memorize that equation. Our maximum value is 0.5 and our minimum value is negative 0.5. So to find the amplitude, we're going to do 0.5 minus negative 0.5, so plus 0.5 over 2. 0.5 plus 0.5 is 1 divided by 2 gives us an amplitude of 0.5 or 1/2. For our second example, our maximum value is positive 3, minimum value is negative 3. So our amplitude is going to be 3 minus negative 3, so 3 plus 3 over 2. 3 plus 3 is 6 divided by 2 gives us 3. So amplitude of the first function is 0.5. Amplitude of the second function is positive 3. So here's a summary box that lists all the properties of sine functions. We can always figure out our amplitude and our period by looking at the graph, but these make it a little bit easier to figure everything out just by looking at our equation. So suppose you have an equation y equals a sine of b theta, with a not equal to 0, b greater than 0, and theta in radians. The absolute value of a is the amplitude of the function. So if we have our function y equals a sine of b theta, a is the amplitude, absolute value of a, so it's always going to be positive. B is the number of cycles in the interval from 0 to 2 pi. That's very important. So it tells us the number of cycles from 0 to 2 pi. So B is the number of cycles from 0 to 2 pi. And 2 pi over b is the period of the function. So to figure out your period, just like we did in the previous example, you have to do 2 pi over b to get your period. Because 2 pi is the range, the interval that we're talking about, divided by the number of cycles gives you the period. And we can use these properties as well as 5 points equally spaced through one cycle to sketch a sine curve. For all a values greater than 0, the 5-point pattern for our sine curve is 0, max, 0, min, 0. So if you think about a graph, that's what's going to create this curve. We go from 0 to our maximum point, back to 0 to our minimum point, and back to 0. So 0, max, 0, min, 0 is what gives us this sine curve. And to determine the key points that we're going to graph, the values for the 5-point pattern, first you have to determine the period. And we know from the last slide we determine the period by doing 2 pi over b. That's the first thing you have to do. Once you find the period, you have to figure out your new period by dividing by 4. So we take 2 pi over b and then divide that value by 4. And the reason you're dividing by 4 is that's going to give you 5 different points on your graph. And you add intervals until the period is reached. So whatever your new period is, you're going to start at 0 and then add those intervals until you get through one full period. That's for your x values. To determine the y values, you multiply the pattern by a. So remember, our pattern is 0, max, 0, min, 0. And in a regular sine function, our max and our min is going to be positive 1 and negative 1. That's going to change depending on the amplitude, which is a. So to figure out your y values, you're going to multiply this pattern by your a value. So 0 times a is 0. 1 times a is a. 0 times a is 0, negative 1 times a is negative a, and 0 times a is back to 0. So basically, your minimum and your maximum values, your y values, is just determined by the amplitude. It's either positive or negative. So let's look at an example for sketching. So sketch 2 cycles of y equals sine of theta using the 5 points. So first thing we have to do is determine the period of y equals sine theta. The period, we know, is 2 pi over b. In this function, b is 1, so our period is just going to be 2 pi. Next step when we're sketching, we have to divide that by 4. So 2 pi over 4, when we simplify, gives us pi over 2. Once we have this value, we're going to keep adding intervals until we get back to the original period. So this interval pi over 2 is telling us how far apart our key points are on the x-axis. So whatever this number is that we get after dividing our period by 4, that's going to be our increments along the x-axis. So we always start at the origin, which is 0. Then we get to pi over 2. Pi over 2 plus pi over 2 gives us pi. Plus pi over 2 is 3 pi over 2. Plus pi over 2 is 2 pi, and so on. We can also label it in the negative direction. So instead we're going to subtract. So this is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and so on. So that's what helps us label our x-axis. Our y-axis, we have to think about the amplitude. The amplitude of this function is 1, which means that our maximum and our minimum values are going to be positive 1 and negative 1. So I'm going to mark that here, positive 1 and negative 1. So now when we go to sketch our graph, always start at the origin. The sine function always goes through your origin. So to figure out the rest of our points, we can use the pattern for when a is greater than 0. We go from 0 to the max, to 0 to the min, back to 0. So here are our 5 key points for this graph. So that's one cycle of our graph, and we can sketch it to look something like this. Actually, don't bring that tail up on the end too high, because as it continues, we're going to go back to the max and back to the min and so on. But notice it says sketch 2 cycles. So our other cycle we're going to sketch on the negative x-axis. So notice from 0 we went to the max, to 0 to the min, back to 0. In the negative x-axis we're going to do the opposite to keep this sine curve. So from 0 we go to the min, to 0, to the max, and back to 0. So we can sketch another cycle on this side of our graph to look something like this. So here are 2 cycles of y equals sine of theta using our 5 key points. Another example, sketch 2 cycles of y equals 2 sine of theta using the 5 points. So now we have our equation, y equals 2 sine of theta. So right from the start, we can, looking at this equation, determine that our amplitude is going to be 2. And our amplitude is going to help us figure out our maximum and our minimum values on the graph. So the maximum y value on this graph is going to be at positive 2, and the minimum y value on this graph is going to be at negative 2 based off the amplitude. And I'm going to label my y-axis. To figure out our x values, our 5 points for the x values, then we need to use the period. So the period of this function, again, we do 2 pi over b. There's no b value. B would be the number that's in front of theta. So our period here is 2 pi. After we have the period, we have to divide that by 4 to figure out the intervals for our x values. So 2 pi over 4 gives us an interval again of pi over 2. And notice in this function, we have a y value, but there's no x value. Now x is represented as theta, so I'm going to label my x-axis as theta because those are the values that it's representing in our equation. So my interval, again, is pi over 2. Now we can label our x-axis or our theta axis. So first point is pi over 2, and then we're just adding this value until we get to 2 pi. So pi over 2, then that takes us to pi, to 3 pi over 2, and then to 2 pi. We can do the same thing on the negative x-axis. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So now because this pi over 2 is representing our theta, that's our interval, we can rewrite this equation as y equals 2 times sine of pi over 2. This interval, we can write it into our equation. So now our 5 key points, we're always starting at 0, don't forget. then we follow this pattern. The max, we go from 0 to the max, and we know our maximum is positive 2, back to 0, to the minimum, which is negative 2, and back to 0. So the right side of our graph, if we sketch, looks something like this. And then we can sketch another cycle on the negative theta axis. So from 0, we go to the minimum, back to 0, to the maximum, and back to 0. So another cycle of this graph looks something like this. Okay, so next example for sketching. Sketch 2 cycles of y equals negative 3 sine of theta using the 5 points. So now we have y equals negative 3 sine of theta. And notice in the last 3 examples, the only thing that has changed is our a value, or our amplitude. Our b value in all of these has been 1, which means that our intervals or our period amongst these 3 examples has not changed. The only thing that has been changing is the amplitude. On the next slides, we're going to get into a couple of examples where our period is changing as well. So let's start with this. Y equals negative 3 sine of theta. So our amplitude, remember, we keep it positive. So our amplitude is going to be 3. This negative symbol is going to change our pattern that we use to figure out our key points. So our amplitude is 3, which means on our y-axis, our maximum value is going to be positive 3, and our minimum value is going to be negative 3. And on our theta axis, we're going to use the period to mark off the intervals. So the period of this function, again, there's no b value, so our period is just going to be 2 pi. To figure out the intervals that we're using on our theta axis, we do 2 pi over 4, which simplifies to pi over 2. So this is staying the same as the last few examples. So we use pi over 2 to label our theta axis. So from 0, we go to pi over 2, to pi, 3 pi over 2, and 2 pi. And I'm going to label my negative theta axis as well so that we can sketch out the 2 full cycles. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So now we're able to sketch. So remember in the last 2 examples, our a value, which is the value in front of sine, was positive, which gave us the pattern from 0, we go to max, then to 0 to min, and back to 0. That's if it's positive. Now if it's negative, this pattern just flips. So if it's negative, we go from 0 to the min, to 0 to the max, back to 0. So our pattern is just flipping. We're still starting at the origin always for our sine functions. So now from 0, we're going to the min, which is negative 3, back to 0, to the max, and back to 0. So we can sketch out the right side of our graph, something like this. So that's the right side of our graph. That's one cycle. The other cycle we can do on our negative theta axis. So now we're going from 0 to the max, back to 0, to the min, and 0. So the left side of our graph can be sketched like this. So if your a value is negative, that's just flipping your pattern. Rather than going from 0 to the max, you're going from 0 to the min. And the last few examples that we're going over for this section are where the period is going to be different. So sketch 2 cycles of y equals sine 2 theta using the 5 points. Remember the original equation we're working off of is y equals a sine b theta, where a is the amplitude and it tells us our maximum minimum values, and b is the number of cycles from the interval of 0 to 2 pi, and b also changes the period of our function. So we have y equals sine of 2 theta. First, it's easy to determine the amplitude. The a value here is 1, which means that our maximum and minimum values of this graph are going to be at 1 and negative 1. So we're not going to have any y values greater than 1 or any y values less than negative 1. The period, remember we find by doing 2 pi over b. So we have 2 pi over, the b value in this equation is 2. So 2 pi over 2, which means that our period is pi. Now to figure out the intervals between our key points, we then divide the period by 4. So pi divided by 4 doesn't simplify any further. So along our theta axis, we're going to be moving in intervals of pi over 4. So we have 0. Our first point is pi over 4. Our next point, add pi over 4, we get pi over 2. Our next point is 3 pi over 4. And then we have pi. We're going to do the same thing in the negative theta direction. So we have negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. And we get these key points, remember, by adding this. So we start at pi over 4, then we add pi over 4 again. We get 2 pi over 4, which simplifies to pi over 2. So you're always simplifying your fractions. Now when we try to sketch our graph, remember, sine functions always go through our origin. Because our a value is 1, positive 1, that means our pattern is from 0. We go to the max at the next point on our theta axis. Then we go back to 0. Then we go to the minimum and then back to 0. So we can sketch the right side of our graph like this. Then our other cycle is going to be in the negative theta direction. So from 0, we go to the min for our first interval point. Then we go back to 0, then to the max, and back to 0. So we sketch the left side of our graph like this. Our next example, sketch 2 cycles of negative sine theta over 2 using the 5 points. So we have y equals negative sine theta over 2. So again, we can start by thinking about the amplitude. Gives us our max and min points, and the amplitude is we get from the absolute value of a. So in this case, even though a is negative, when we take the absolute value of -1, we get +1. So our maximum point is going to be +1, minimum point is going to be -1. This negative is important though because it's going to change the pattern. We don't go from 0 to the max now, we go from 0 to the min. The period of this function we get, again, by doing 2 pi over b, 2 pi over our b value. In this case, we have theta over 2, so our b value is 1 over 2. 2 pi divided by 1/2, we can multiply by the reciprocal, so 2 pi times 2 gives us 4 pi. So the period of this function is 4 pi. To figure out our intervals, where our key points are going to be, we divide that by 4. So 4 pi divided by 4 gives us intervals of pi. So along our theta axis, we're going to be increasing and decreasing in intervals of pi. So from 0, our first point is going to be pi, add pi to get our second point, 2 pi, 3 pi, 4 pi, and so on. We're going to do the same thing in the negative direction. So we have negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. Now from here, we're able to sketch our graph. So we're always starting at the origin, 0, 0. Now because this negative, we have a is negative, that means our pattern is from 0 to the min. So at our first point on our theta axis, we're going to the minimum, then back to 0, then to the max, and then back to 0. And the left side of our graph, to keep this sine curve, we're going to go from 0 to the maximum, back to 0 to the minimum, back to 0, and we can sketch this cycle. So those are 2 full cycles of y equals negative sine theta over 2 using our 5 key points. Next example, sketch 2 cycles of y equals negative 2 sine pi theta using the 5 points. So you'll notice again in this example, we have negative a, which means that rather than going from 0 to the maximum, we're going from 0 to the minimum for our pattern. We also know, given this information, that the amplitude of this graph is 2. Amplitude is, we get that from the absolute value of a. So our maximum of this graph is going to be at positive 2. And the minimum of this graph is going to be at negative 2. So that's all we know about our y values. Next, we have to figure out the period. Period is going to be 2 pi over b. In this case, remember, b is the value in front of theta. Our b value is pi. So we're doing 2 pi over pi, which just leaves us with 2. The key points, next step, to figure out our key points is divide the period by 4. So we're doing 2 over 4, which simplifies to 1/2. So on our theta axis, we're moving in intervals of 1/2. So we can label everything. We start at the origin at 0, then we're at 1/2, and we're adding 1/2 each time. So we get to 1, then 3/2, and 2. And I'm going to label it in the negative direction as well. Negative 1/2, negative 1, negative 3/2, and 2. So now when we sketch our graph, always start at the origin. Because our a value is negative, we're going to our minimum first. So at our first key point, we're at negative 2, then back to 0, up to positive 2, and back to 0. So the right side of our graph looks like this. And we're going to follow that pattern to sketch the left side of our graph. So at negative 1/2, we're at the max, which is positive 2. Then we go back to 0, down to the minimum, and back to 0. So the left side of our graph looks like this, and those are 2 full cycles of y equals negative 2 sine pi theta. And last example for sketching our graph using the 5 key points. Sketch 2 cycles of y equals 1.5 sine 3 theta using the 5 points. So we can start by figuring out the amplitude of this graph is 1.5. So our maximum value on this graph is going to be at 1.5. Minimum value on this graph is going to be at negative 1.5. Next, we have to figure out the period so that we can determine our key points. So the period of this function we get by doing 2 pi over b. The b value in this case is 3, so 2 pi over 3 is our period. We can't simplify any further. The key points we get by dividing our period by 4. So 2 pi over 3 divided by 4 is the same as multiplying by the reciprocal, so we can multiply by 1 over 4. And when we multiply, we can simplify. 2 becomes 1, 4 becomes 2. So our interval for our key points is going to be pi over 6. So now we can label our theta axis. So we start at the origin, which is 0, and then we're moving in intervals of pi over 6. So we have pi over 6. If we add pi over 6, we get 2 pi over 6, which simplifies to pi over 3. Add pi over 6 becomes pi over 2. And add pi over 6 again, it becomes 2 pi over 3. Same thing in the negative direction. We have negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3. So once we have everything labeled, we can sketch our graph. We're starting at the origin, 0, 0. Because our a value is positive, we're using the pattern 0, max, 0, min, 0. So our max at pi over 6, remember, is at 1.5. So I'm going right in between 1 and 2. And then we go back to 0, then down to our min, which is negative 1.5, and back to 0. So the right side of our graph looks like this. Follow the same pattern to sketch the left side of our graph. So we go down to the minimum, back to 0, up to the maximum, and back to 0. And the left side of our graph looks something like this. So that's it for section 4 and for sine functions. Take your time, do a lot of practice graphing. If you have any questions, please let me know. Your homework is posted to Google Classroom. Good luck.